All right. This is the problem we're on, right? Okay. So we want to find f prime of x. That's the derivative of f of x, or the instantaneous rate of change, or the slope at a given point. Okay? We want to find the derivative for this function using the limit definition of derivative. That's the only way we'll be finding the derivative on this test, the limit definition of derivative. And so these are like, I don't know, I haven't written the test yet, but like 10-point problems, say, and you got to show all your work. I'm not just looking at the answer. So you get 1 point for doing what? Writing down the definition of derivative. So we're going to write down the limit definition of derivative here. Boom. So the limit as h goes to 0 of f of x plus h minus f of x over h. Hopefully most of you got that in your head now. Again, things point out, it is h going to 0, not x. And it's a minus sign. All right, so I've got 3 things that I need to replace. Well, I guess h you really don't need to replace. But f of x plus h, I need to up here, every time I see an x, and there's 2 x's. There's one on top, there's one on bottom. Everywhere I see an x, I'm going to replace it with x plus h. Okay? So instead of 2x minus 5, I have 2x plus h minus 5. And on the bottom, instead of 8 plus x, I have 8 plus x plus h. So the yellow part here is representing my f of x plus h. Then when it just says minus f of x, it just means minus, put this exact function in, all over h. Things to be careful with. When you subtract off f of x, make sure you put parentheses around it, because we want to be subtracting off that whole thing. All right, so the ideal thing is when you're taking the limit as h is approaching a number, we want to put the number in. So putting 0 in for h right now would cause the denominator to be 0. Can't do it. So we're going to have to factor, cancel, try again. The factor part's going to take a bit of time here. Looking at the yellow part for factoring, if I multiply the 2 through, I'd get 2x plus 2h minus 5. Down here, if you distribute that plus sign, it just takes away the parentheses. Up here, not a lot I can do yet. I don't want to distribute the negative. A lot of people try to distribute the negative on top and bottom, which undoes it. You can only distribute it one way. So my suggestion is to keep your negative right where it's at until you get a common denominator. So on my next step, all I did was distribute the 2 across. So I distributed this 2x plus 2h. And then down here, I took away the parentheses because I distributed the plus sign. Okay, so at this point, we want to subtract these 2 terms, but the denominators are totally different. This says 8 plus x plus h, and this one says 8 plus x. We want to get a common denominator going on here. So if this were just like 8 and 5, common denominator would be 40. We'd want to multiply the first one by 5 over 5 and the second one by 8 over 8. Same thing even though we're talking about letters. So this one has the 8 plus x plus h. It's missing the 8 plus x. So I want to multiply it by 8 plus x over 8 plus x. Right there, 8 plus x over 8 plus x. The second one has the 8 plus x already. It's missing the other denominator. So I want to multiply it by 8 plus x plus h over 8 plus x plus h. So this is me getting common denominators here. Multiplying this side by 1, multiplying that side by 1. So once we multiplied by this common denominator, we now need to multiply through. Now this is like foiling, but on steroids here, because it's not like a binomial times a binomial. We have 3 terms going on here. So the first thing I'm going to do is put parentheses right there. So I know that I'm just doing the whole thing. Same thing on the bottom down here. Okay. So then I want to multiply. Now I'm going to put my parentheses there also. So I'm going to be kind of foiling here. I'm going to multiply this 2x to the 8. So I do this in pieces here. Hold on. 2x times 8, and that gives me 16x. Okay? So I recommend not writing this down 100 miles an hour because I'm going to walk you through it slowly. So 2x times 8 is 16x. Y'all with me so far? The next one would be 2x times x, which gives me 2x squared. So I'm done with the 2x. I'm going to move over to the 2h. 2h times 8 gives me 16h. And then 2h times x gives me 2xh. So I'm done with that one now. So I'm going to move over to the negative 5. Negative 5 times 8 gives me negative 40. And negative 5 times x gives me negative 5x. So I'm going to pause a second. I'm done with the left side. I ultimately foiled whatever it's called, foiled on steroids, all that out. All right? So then I got my minus sign. For some reason, this minus sign likes to disappear on people's papers when they're doing these long problems. Make sure you've got that minus sign, and then whatever's about to come, you're going to have huge parentheses because you're going to subtract off whatever's about to come. Okay, and I'm going to do it in parts with you here. So minus, parentheses. The first one is 2x times 8, which is 16x. And then I'll do 2x times x, which is 2x squared. Then we have 2x times h, which is 2xh. Okay, so now I'm done with the 2x. I'll move over to the negative 5. Negative 5 times 8 is negative 40. Negative 5 times x is negative 5x. And negative 5 times h is negative 5h. So I multiplied all the left, and then I got my big minus sign in the middle, and then I multiplied out all the right. You with me? Okay. Now look at my denominators. These are common denominators. They're the exact same ones. So what I'm going to do is I'm going to put those together. What I do here, I typically don't make a new line. I don't remember what I did on the PowerPoint. But I typically right above it distribute my negative sign and say negative 16x minus 2x squared minus 2xh plus 40. And I just distribute it all across right there instead of making a whole new thing. Again, I don't remember what I did here, so let's see. Distribute negative sign. Oh, yep, I made a whole new one for that one. But that's just me. You can do it right above yours if you want to. So all I did on this one was I put it over my common denominator. So I just combined them over my common denominator, so I have one denominator, and I distributed my negative all the way through. Okay. Again, if I were really doing this problem, I wouldn't write this all out again. I'd just distribute the negative right above it. Are y'all with me? Good thing about these horribly long, ugly problems is if you did it correctly, the only thing that's going to be left in the numerator will have an h in it. Okay, if you have terms that don't have an h in the numerator, you're doing something wrong. So we have 16x minus 16x. Then we have 2x squared minus 2x squared. 2xh minus 2xh. Negative 40 plus 40. Negative 5x plus 5x. So all I have left is the 16h over here and the 5h right there. That's all I have left. And that'll work every single time if you do this right. All you have left with terms that have h's in them. So if I add 16h plus 5h, what does that give me? 21h. 21h. All right. So we have 21h over all this. This h on the bottom is really h over 1, so instead of dividing by h, we can multiply by the reciprocal. And this is what we've been working up to. Now we have these h's can cancel. So as soon as we cancel those h's, we're finally able to take the limit as h goes to 0. We can now plug 0 in for h, and it will not cause the denominator to be 0. So plugging 0 in right there for h. I'm going to be left with, and notice I did not write limit as h goes to 0 this time because I just took the limit. I'm done with that. So all I have left is 21 over, that was 8 plus x plus 0, so 8 plus x times 8 plus x, which we will typically write as 8 plus x squared. We don't want to FOIL that out. Why, you might ask? When we start doing stuff with this later, doing the shortcut rule, not the long way, this will be the way we will want it and not FOIL it out because life will be easier, just trust me. So this is my long example of limit definition of derivative. All right, so it says sketch a graph of and find the equation of the secant line. So if we were just to find the slope of the secant line, we could do that. We were given the function, we're given two x values. How would we find the y values that go with them? Plug them in. So we plug them in to get the two y values. So then we have 2 points. Once you have 2 points, you can find the slope, y2 minus y1 over x2 minus x1. But that's not all we're doing here. We're actually finding the equation of this line. So you don't really have to sketch it. I mean, you can if you want to, but you can just think this is an upside down parabola. So this is what it looks like. And there's 2 points happening here, and there's a line going through it. I'm not really going to be asking you to sketch it. I just want you to see what's going on from my example here. Even on the test. And so here's my graph, here's my function. Actually, you're going to need to sketch it for the next part anyway, so let's do that. Go ahead and go to your calculators. I'll give you a second to get your calculator out. Those of you who have your calculator. Okay, hopefully you've graphed before. If not, hang with me here. So go to y equals, up in the top left corner right here of your calculator, y equals. And in y1, you're going to type in 6 minus x squared. If this is new to you, make sure you type in the subtraction sign and not the negative sign that's at the bottom of the page. And then there's an actual x button right around here that you use for your x. If you're having trouble, ask your neighbor. And then just to get a normal standard window going on for right now, hit zoom 6. Zoom is in the middle right here. Zoom 6, and that's a standard window. All right. So finding our y values by hand here. If I did f of -1, it'd be 6 minus -1 squared, which is 6 minus 1, which is 5. And so my first point is going to be -1, 5, which I have plotted right there. F of 3, 6 minus 3 squared, would be 6 minus 9, which is -3. So that point is 3, -3. So these are my 2 points, and I plotted that one there. And what I'm wanting to do is find the equation of the secant line. So the equation of it. So the equation of a line is y equals mx plus b. We can find our slope by doing y2 minus y1 over x2 minus x1. All right, so we did that, we got our 2 points. All right, so now we can find our slope. Our slope is y2 minus y1 over x2 minus x1. So I just did y minus y over x minus x. So I get 8 over -4, which is -2. So the slope of the secant line is -2. And remember, secant line means you have 2 legitimate points and it's cutting through the parabola twice. Okay. Once you have the slope, then in the equation y equals mx plus b, we can replace that m right there with a -2. So we have y equals -2x plus b. We just need to find the b value. And we can find that b value by plugging in either one of these points for x and y. There's an xy, there's an xy. We can plug in either one. So I'm going to just plug in the the first one here. So I put a 5 in for my y equals my slope, which is -2, times the x, which is -1, plus b. So I just put my first point in. -2 times -1 is 2. And I can subtract that to the other side, and I'll get 3 equals b. So now I have the equation of my secant line to be y equals -2x plus 3. Okay, so this part A was an algebra question. You did this back in algebra. Given 2 points, find the equation of a line. That's what we just did. Part B takes the same problem and turns it into a calculus problem. It says find the equation of a tangent line. So a tangent line is a line that touches a parabola at exactly 1 point. So let's see what picture of that would look like. Well, I just have it graphed right now. But at x equals -1, it's just going to be plotted right there and have a line. That's a tangent line. So to find the equation of a line y equals mx plus b, the slope of the tangent line is called what? Slope of a tangent line. Derivative. Slope of the tangent line is called the derivative. Okay? Right now, the only way we know how to take the derivative is the limit definition of derivative. However, good news. If it's asking you to find the equation of a tangent line at a point, I will let you use your calculator because there is a feature on your calculator that will do this for us. Okay? Everything else we've been doing, there is no feature. That's why we've been doing it all by hand. So I'm very pro calculator. If we can use it, we're going to. Do I feel guilty? You're not doing this by hand? No, later on we're going to have extra variables involved and you have to do it by hand. We'll just learn it then. No need to overload you now. So I'm about to show you how to find the equation. This only works for when you're finding the equation of a tangent line. Okay, so you graph it in y1, which I've already done. And you did like Zoom 6 or something, so you're looking at it. Everybody looking at it? Okay, if you don't have your calculator, you're going to really want to write this down. You're going to go to second draw. So you have to hit your second button, and draw is somewhere in the middle of your calculator behind program. So second draw, it's your program button. Are y'all there? The fifth one down should say tangent. You got it? Second draw, the fifth one down should say tangent. Choose that one, hit enter. That's what it's looking like. Okay. When you hit enter, it'll look like nothing's happened, and that's because nothing has happened. You haven't told it where to draw it yet. So once you hit enter, you have to then type the x value where you want to find the equation of the line. In this case, it's -1. So you want to type -1, enter. And it will draw the line for you. And at the bottom of your screen, it'll tell you the equation. So it draws the equation of a tangent line. And down here at the bottom, it says y equals 2x plus 7. Okay. Now, some of yours might say y equals 1.99999. Anyone? It will. And then some of you will say 2.000000001. We're smart people. We know it's 2. Okay, don't put 1.999. It's 2. Okay. So the equation's at the bottom of the screen. This is our equation of our tangent line. All right, so what I want to do, I've got to pull up something to write on.